Testing, 1, 2, testing. Looks like we're live. Don't hear myself yet, got a delay. Ah, there we go. Very cool. So I have a special thing tonight. I got some Stentors, very, very large ciliates from the local Maker Faire yesterday, from a guy doing research on them. Pretty interesting research. I can talk about it later. But first things first, I need to just get a couple quick things set up here. Oh, and unfortunately, I forgot to turn off that response thing with the heart. That gets really annoying and blocks some of the chat. There is a way to turn it off. I found it, but I forgot to do it. So just bear with it for the stream. I'll turn it off next time. God, that's annoying. Okay. And another addition for tonight, other than Stentors for the first time, is have a special guest soundtrack by my friend Henrik, who goes under the name JX3D. He has a Bandcamp site with all kinds of cool albums of electronic music. And I picked one that was a little more ambient to match the he has a lot of ambient and mixed stuff on there, which is really good. But this one seemed to fit tonight for the kind of ominous large Stentors that we're going to showcase here. So I will put the just so you can see. That's who he is and where he is. And here's a link to the album that I'm going to be streaming tonight in the background. I'm just going to let it loop a couple times because it ends up being just long enough to have it loop around and have it be fresh, because the stream might only be about an hour or two tonight. So we'll see how that goes. It's all about Stentors, so I can't go too long about them, even though they're really cool animals. And here's the link to his Bandcamp for the album. Please go on there and go to the main page and check the rest of his albums out. He's a good guy and he makes good stuff. So very grateful for him to allow me to stream it on here, have some different music for a change instead of just some random ambient stuff from the internet or ambient generators. I have some stuff I can string together, but I have some of my music and some of the other videos, and a lot of my stuff is a mix of ambient and other things. And it's just been nice to have some different music on here for a change that's you haven't heard maybe, and just something fresh. And I have some other friends asking me about this, so I'll be showcasing some other folks in future streams. So stay tuned for that, please. Okay. So I'm gonna, now that I can hear, I'm okay, I'm gonna mute the YouTube video. Sounds like it's okay, so I don't double talk and confuse myself. And I'm gonna start his music. So here we go. Here's JX3D. Bear with me while I balance it a little bit so I can still talk. should be a good volume. Knock it down just a tad more. That's probably good right there, so you can still hear me. Just a tiny bit more down. Sorry, I have to test this with YouTube and the time delays here. I think that will work. Yeah, that's pretty good. In a future stream, I may play this again with more music volume and less talking, just so you can enjoy it with the backgrounds. Just don't want to make it too low and still hear what I'm discussing about the critters here. So I'm going to leave it there for now. Some of the tracks, he does a good job of remixing and balancing his stuff, mastering, so the volumes all should be pretty consistent. Turn it up just a tad. That was too low. Let me fix it. Oh, that was the track end. Okay, I'm gonna leave it there. That should be pretty good. Apologies, Henrik, if you tune in and it does seem a little low, but I just want to be able to talk at the same time. So nobody in the stream yet, just me talking to the world here, so that's fine. I didn't make a last-minute stream, it wasn't announced. And for some folks it is late. Okay, so here we are, Stentors. So at the Maker Faire, this guy's doing research on Stentors, and I got some last time, but I didn't have a good microscope several years ago when I got some samples from him. These are very large ciliates, kind of conical, and have a large oral kind of groove area where they bring in material and will create food vacuoles, just like a paramecium would do, to bring it into the cell. Because remember, it is one giant cell. So what I'm first going to show you on my dissecting scope here is how big they are. This is the typical sample vial. It's about 10 milliliters, something like that. And if you look at the bottom here, I can focus on them. You should see some guys swimming around in here, in this algae debris in there and stuff. See those big lines right there moving? Those are Stentors. So, and they are naked eye as little lines if you hold them up to the light. Paramecium at this level, you wouldn't see them. You'd see them as a swarm, but not as individuals like this. So these are very large ciliates. So what I'm going to do is transfer some to this water tray I have here, and still keep them low magnification, just so you can appreciate how big they are. So if I can do this without taking too many of them out. Don't think I got any yet. I think he only gave me a couple because he only had so many for his demo at the show. So I'm gonna have to hope that I'm transferring them correctly here. Now let's focus on the actual tray and see if I got any here. Zoom out a little bit. Turn the brightness down. And then I'm going to use the backlight now to make them stand out a little bit more. Kill the overhead light and use the transmission light just like I do on the other scope. See if I can find them. Funny thing about the larger animals, you're so used to looking at smaller animals on the scope that sometimes you don't even think to look for them. You'll blow right past them at the higher magnification because they're so big. Okay, looks like I didn't get any yet. They're still in the tube. Let's go back to this view again. Just stir them up a little bit here. It's just the transmitted light. And so if we got any transferred. So just some of the algae debris he had in his collection. So I'm being careful, partly because I want to show you the size difference in an isolated setting, but also because he only gave me a couple of them. So I want to make sure I get at least one out of here. There should be a couple in this bit. And there could be other things in here too. There's some bits of algae there still. Or Stentor that I could find. What is that guy? That's something else. That's just some debris moving around. I have a fair amount of water in this dish, so could easily be all kinds of things cruising around in here. This is also algae, I believe, over here. Oh, I also have some dirt on the cleaner, so it's more pure white. There, mostly it's just from the tray now. Okay, so I still have to go fishing here. Fishing for Stentors. Hopefully not clinging to the edge of this test tube. That would be unfortunate. Oh, I think someone came out. I think I got one. Zoom out to make the search a little bit easier. I did see a pretty big item come out. That's just water at the bottom. I should wipe that because it's confusing to see that. Hold on a second here. These guys have a habit of kind of bunching up when they get disturbed. It just looks like debris there. Oh, wait a minute. Is that one there? I think we got a couple there. I believe those are guys, my little Stentors. Little conical things. Yeah. There we go. So when they open up, they kind of flare out like little cones. So now it's swimming in circles. And they have this kind of like the, I think of the original Star Trek series of William Shatner. And the big doomsday device that comes to swallow, it's like a horn of plenty coming to swallow planets, basically. These guys are swimming in unison here. That's pretty cool. So I have at least two in here. That's cool. Now if I zoom in quite a bit, it's a little hard to navigate because it's in a dish full of water here, but so this isn't a beautiful view because they're still pretty small in this dissecting scope. But just for comparison's sake, let's see if I can drop this nearby them without disturbing them. I'm going to put... get near them here. Without smashing them. Drop because it got wet. Hold on a second. Let's use my fingers. This is not working too well with the forceps here. So that huge ball There's a coriander seed. Trying to not run over the Stentors with the coriander seed. But I want to give you an example of scale. I don't have any sesame seeds handy, so there's the tip of my pipette, so you get an idea how big they are compared to my pipette. So I'll be sucking one up in a little bit to take them over to the other microscope. But let me move over the coriander seed here a little bit, just gently. It's floating, so it's not going to, shouldn't hurt them. It's like a massive beach ball above the... There you go. See, there's a... You can just see the edge of the coriander seed in the Stentor. So these ones are they're bigger than this. So this is not the biggest one you can find. It's like a giant asteroid there in comparison to the Stentor. And this coriander seed in this angle is about 4 or 5 millimeters in size. So my pipette is the coriander seed, and they're 2 little Stentors. Obviously, a tardigrade is quite a bit bigger, and some nematodes. But these are pretty good sized ciliates. So I'm going to leave one alone so he can do his little thing. I'm going to steal one of these guys with my pipette. Again, there's the coriander seed. And there are the Stentors. No, don't hit the Stentors. I think it's floating, so I think we're okay. Let's get my pipette in here. Steal this guy carefully. Don't grab the coriander seed. Alright, I'm gonna have to do this very carefully. I don't have my micro pipette man handy, so I have to be more precise with this crude plastic pipette. Get out of there, coriander seed, you're in the way. There's the pipette, there's the tip. Let me navigate this better so you can see the whole process while I suck one of these guys up. No, he's under the seat. Get out of there. Get away from him. Move the seat all the way out of the way. It's really bothering me here. Okay, here's the pipette. Oops. I squeezed when I should have released. Where'd you guys go? Get back here. No, that's not it. There they are. And they're hanging out together. That's pretty good. There's the pipette. Go in the water. Suck them up. Oh, I think I got both of them. Might be too much water in the slide, but at least I got both of them, I think. So let's swap over to the other camera. Turn this light down so it won't bother these guys. Put a nice cover slip on here. So make sure it's a nice clean cover slip. This might be the only good view I have of these guys. That's pretty good. Okay, now we're going on the other scope. Get the color temperature up here. It's too bright on this tool, so let's turn it down. Let's auto expose, drop it down here. Drop this down. Alright, let's go find these guys. Should be very easy. These are big boys. Oh, there's one caught in the cover slip. Very nice. Right on the edge of the cover slip. Hey, Teeny. Got some Stentors here. Haven't looked at these guys in a long time, but got them at the Maker Faire yesterday from a really cool guy who's doing research on them. Gave me some for free. There we go. Beautiful. So see, they have the nice striations like a blepharisma, but a very distinct shape like a cone with a big hole in the center. And you can see the cilia buzzing around in there. Nice green color. Turn this down a tad here. See, I put a little too much water, so I have to be careful with my movements. I'm shaking the hell out of this thing. Yeah, come back when you can, Teeny. Stentor action. Good stuff. Give it a little more contrast here. Need to play with this lighting a little bit. The green is not quite showing through like it should. There's a second one in here too. I will check it out later. It probably looks pretty much identical, but you never know. So now that I'm got a good view of it, I'm just following it around. Boy, it's really cool because it rotates. You can see the kind of spiral structure inside. That is really cool. Nice. Let me do a quick check on the, I think my focus on scope is slightly different from the focus on screen here. Those are pretty in line now. Just gotta play with the contrast settings. Get a little bit of that green color now if I do this. Actually, let's try some. Gonna do dark field. There's some oblique lighting here. patch stop in there for this eyepiece. I can cheat and do a little bit of a digital zoom here for now, just to. See, as it rotates, you can see the structure in layers. Really interesting. There's clearly a defined wider part at the top. Not quite perfectly conical, but very different than other ciliates that I've seen. Almost like a little funnel. Let me get the right patch stop for this eyepiece. This is the wrong one. Not that one, not that one, not that one. Could be this one. Or could be this one. I bet it's this one. I could use the dark field, hopefully, if I get this right. No, still the wrong one. Let's try the next step up. There we go, we get some oblique lighting here at least. Where did you go? There you are. The condenser's set wrong too. Oh, you can see it contract there. Look at that. See? When it's not happy, they go into a little ball. And then they slowly unfurl. There's a nice bit of dark field there. Between oblique and dark field. They get disturbed, they contract, and then they slowly spread back out so they're protected. And what the guy was doing in his research was studying, they seem to have a memory, and they're not quite sure the mechanism yet. It's like a chemical memory. And so what if you do fairly rapid fire stimulation to bang them with some debris or with some kind of other stimulus, they kind of go, I don't like that. And they'll continue to coil, but there's a certain frequency where they won't do that anymore. And at some point they will stop reacting at that frequency for quite a while. It's like a memory they develop, like, hey, I'm wasting energy folding up constantly and unfurling. Everything takes energy, right? So they basically say, their instinct is that's not good, and so they basically stop doing it, and they can get that to repeat. And what they were trying to do is see if there it goes, it just got triggered again for who knows what. I don't think I banged it, but and I'd have to read the whole paper. He had a really brief description of it, but when I first saw him several years ago at the Maker Faire, and they were just starting this research, it was a disturbance frequency causing it to unfurl, and then certain frequency they stop responding, and over a period of time they will stop responding. And if you change the frequency again, at some point they will forget the frequency that made them stop caring anymore, and they'll continue to contract again. But then they did some further research and discovered that thinking it might be a chemical messenger type of thing, where a protein is created at the point of the lack of stimulation, and if they could turn off some mechanisms that create those proteins, or disable them in some way, does it continue to happen? And I have this on my little tour video from on my synth channel from Maker Faire the other day, so I'm kind of paraphrasing a lot of it. But basically what he's telling me in that video is they ended up turning off the protein creation process temporarily, but then they couldn't turn off the lack of response. So then you would change the time period, and they would continue not to react, which is obviously not good for them. You want to have protection. So they're trying to figure out what that is. He's also trying to see if further generations, as they divide, will inherit this learning of the frequency of not responding. So pretty interesting stuff, because they don't really have a nervous system. It's a single cell, even though it's a very large cell. So therefore, no nervous system, no brain, no complex way of building memories and storing memories like a primitive jellyfish would even have, with their really primitive nervous system. Let's do some dark field here. I love dark field. And unfortunately, it's right on the edge of this cover slip, so it's kind of interfering with the image. Anyway, the research is pretty cool, and it's ongoing. So now I've opened up a dialogue with him, and I'm going to show him some of the footage I've got here. This is, obviously not. This is the first time I've shot Stentors. I'm trying to figure out the best lighting and the best contrast settings and ways to view them, but just really happy to be able to see them because they're really interesting animals. Now it looks like an Erlenmeyer flask upside down. Oh, now it changes shape again. So is that, I didn't really bang it, so is that a temperature thing, a pH thing? I'm not sure. But you can really see it contract in this little ball. So if you saw it like this, you'd think, that's not a Stentor, that looks like a really bizarre little algae, because it has some green color, and although it has those striations which are kind of indicative of certain species of animals. So in this mode, you catch it and you go, oh, that's weird, and you just keep going, and you just bypassed a Stentor not even knowing it, unless you knew about this behavior. Now it's slowly opening up again, looking more like a bleach bottle. Now I want to go up a level, but I got to replace this objective because I'm not happy with this objective. I think it's slightly off what it should be, but let's give it a shot and see what I can see here. Oh, I don't see anything there. Let's go back. I don't like that view. Okay, he's left the view. Or I say he, I should say it. Water droplets there. Some debris. Where did you go, Stentor? There you are, you're still a ball. is I put too much water in. So they're not confined to the cover slip. But then the cover slip may be annoying it too as it's grazing the sharp edge. See if I can oblique light this a little bit so it's a little more 3D. Okay, so now it's at that angle. It hasn't moved. Let me change objectives real quick and see what I can see. Oh, look at that detail. Let's really see the striations there. Man, it looks almost like muscle fiber. Change the lighting here for this. So this objective, the problem is it's got a really bad depth of field, and it's harder to maintain a large object like this in focus. You're getting little segments in focus, but not ideal. And the other objective that I replaced, I got oil immersion by accident in it. It was perfect, and this one's just not a good replacement. I have to track down a better one. But since I'm speaking of oil and I have all my stuff handy, let's go for it, because this guy doesn't appear to be moving. Risk doing an oil shot here. I still haven't found the other one on the slide. It's somewhere on here. See how close I can get to this guy. Somebody moved, I think. I don't see the oil ones. Let me go back to much higher. Oh yeah, it's moving the whole cover slip now. Oh boy. Oh boy. Okay, there's a cover slip. Good thing about putting this oil on the amount of this water on the slide is that it won't be drying out anytime soon as usual. There's plenty more moisture. There's a bunch of cells, but not a stentor. He's still trapped in here? Nope. Not here. Let's go find the other one. The other stentor should be here somewhere. Pretty sure I transferred 2 of them. See the oil on top of the lens there, on top of the cover slip. Oh boy, I could be anywhere in here. Some algae that the guy had in his sample. Let's go way out here and see if it's out here somewhere. More algae. I don't know what that is. I'm tracing the entire body of water here. something in there cruising around. Oh, there's a water flow, so it's not. It's just debris. Where did the Stentor go? These guys are big. Where the hell did it go? It was on the margin of the slide, the cover slip. Can't find it anywhere now. I hope it didn't get transferred to... It was right on the edge of the cover slip and the water. And I'm hoping it didn't get stuck on my oil immersion lens since they touch. It's definitely possible. There's a little gradient there. Some stuff is moving around. I'm not seeing any... Is that moving on its own, or what is that? I think it's just debris. Let's see. Margin of the slide where this thing could have gone. Debris. Let's go back to the water's edge here. You can see some rushing over there. That's where the Stentor was, kind of by that broken piece of cover slip. It's not on a different focal plane, that's the wrong end. What's that shadow there? That's some other junk. Can't find it anywhere. That is bizarre. Should have been two on here, and they're big. It's just some other debris from who knows where. Following the margin of the cover slip, which is where it was tending to hang out. Debris here. I wonder where that second Stentor went. Never found the second one. So I'm whipping around a little faster trying to find it before the slide gets more dry. So I'm not trying to get you guys seasick. Just kind of frustrated that these bigger animals are usually pretty easy to find and stay found. So I'm tracing all the water boundaries here. I just keep finding debris. That's the problem with using the oil immersion lens. Once it starts touching the slides, it compresses the cover slip in the water spreads out, and sometimes things can get stuck on the objective, and you won't be able to tell they're on the oil objective out of focus. Nothing there. Bizarre. Go back to my sample. I should have one or two more in the Petri dish still. Create a whole new slide. Weird. Very weird, very weird. Let's go back to... Let me open... Check the dish here and see what I've got over here. Swap cameras so you guys can see what I'm doing. Back on the hunt for Stentors over here. It's debris. Is that one right there, or is that debris? Could be a dead one. Shape's a little bit off. What I should do is take this stupid coriander seed out of here. I'm sure they're not too happy about that. I don't think in this form it's too unpleasant, but it may have some products that they don't like. Haven't seen any more. Well, there's other things that look like they could be and aren't changing shape. That looks like it could be one. It's got a conical shape a little bit. Could be a dead one. Problem is usually when these things die, as you've seen on my other shows, they tend to lose cohesion and start falling apart. But the shape is very close to what it should be. That looks like one too. It's not doing anything. I'm going to grab one of those and see what it is. Oh, where'd you go? Yeah, that looks like one, but it's not doing anything. Less water this time. Maybe that will work better. Let's do a quick search before I swap the camera. Looks like one that's basically, it's definitely something in a sphere, but it looks different than a stentor, but it has that color. Maybe that's how they die, as a sphere, I don't know. Oh, there's one. Yay, I did get one. Maybe just wanted more light. Alright, let's swap it back over. Stentor, Stentor, Stentor. This one's more closed off on the end. It's usually a wide mouth shape. Great details. You can really see all the vacuoles in there. I might need to make it a little bit too fuzzy if I blow it up digitally too much, but there you go. It's a decent shot of it there. Make sure this matches my view here. Yeah, that's not bad. It's pretty close. So it has that greenish tint. I see some stuff inside of it that looks like ciliate's moving around, so it has a food vacuole with some guy in it. Looks like. I think I'm gonna have to push it a little higher magnification. Let's see. Yep, he's eating something that has some cilia beating inside. That's pretty funny. So you can see the cilia at the edge beating. There you go. Out of focus a little bit. But look at the cilia. If I zoom out, you can see the striations really well there. But if you focus in further, it looks like that giant vacuole with something inside of it has cilia beating. Oh no, I see what that is. That's it's part of the opening with the cilia curved around. Boy, look at all those vacuoles. There's a whole line of them there. That's crazy. Really nice striations. See if I can get a better contrast on those. I can't wait to hook up my my Nikon mirrorless camera. This is still a microscope camera, which is decent, but I forgot to get the adapter for my there's a tube adapter I need for my T adapter to make it fit inside this photo tube, and I forgot to order it, so gotta hurry up. Yeah, that's really cool. You can really see the crown of cilia there at the top. If I tweak the let's try to go to, oh, it just got disturbed. Now you can see the striations really well in this kind of oblique lighting, dark field look here. Get that dumb hand out of there. That looks like a small onion, like a pearl onion. Now the cilia is starting to pop out again and it's starting to open up. And essentially the front part is up, but you see it's moving backward for some reason. There's a little more oblique lighting action, a little more 3D. Well, it's really compressing there. At this focus, you see the striations really nicely. Still don't know what's causing the contractions here, because I'm not really bumping it much. So again, it could be some kind of a chemical thing, or some kind of pH thing, water temperature thing. I don't know what it is. I think they're using an electromagnet to disturb it in their some of their experiments to get it to contract. Not sure if that was because the nature of all the water, because water is a polar molecule. You can actually put water in a very high magnetic field and it'll actually line up. Like, there's a horrible experiment they did. There's in Scientific American back when I was in college, where they actually levitated a frog in a very high magnetic field because of all the water in its body, which of course, at some point killed the frog because of tissue destruction. But before it died, it was levitating. You could see the frog in the middle of this tube as it levitated from the electromagnet, for a high intensity electromagnet. Tweak that. Let's do a little bit of dark field here. That's nice. So it's a little hard to tell in this view, but because of how it's turned. So there's cilia all around the body, but there's a crown of cilia around this kind of opening that it has. And the reason you're seeing this structure like that is it's this rim of cilia, and if you were to rotate it in 3D, where it kind of turns that way, oh, there goes a vacuole. Must be a contractile vacuole for osmoregulation, water salt balance. Watch it open up again. Anyway, when it was moving around earlier, you could see this part here that was also beating with cilia in kind of a circle as part of this kind of it's kind of a whirl of cilia. You could really see it in the first one I found. It was tumbling a lot. If you go back and look at the footage, and almost like when you fold paper into a cone, and you get these kind of curled intersections of the paper comb that curl at different amounts. Creates like a whirl. Oh, is he releasing junk? It looks like it's releasing junk. Look at that. It just released a bunch of junk from some of its vacuoles. It's digested stuff, so it's their version of defecation, essentially. Not vomit, but defecation, because it's digested material. That's pretty cool. If I change the lighting, you can see a little bit better. Little particles. Little light particles heading out to the right there. All this little stuff just got ejected from the cell. I'll try a couple quick shots through the eyepiece with the iPhone. Sometimes these digoscope shots are pretty cool too. If I get some good ones, I'll put it in the stream later. It's not really behaving there. You have to use the if you do use an iPhone bolted to your microscope, there's a good app called DSLR Camera, which I showed on my astronomy stream. That allows you total control over your multiple lenses and your manual exposure, ISO and shutter speed, as well as manual focus. It's pretty nice. That camera at the bottom here. That looks pretty good. This will be good as a comparison for what I get on the webcam, which is actually not webcam, USB cam. It's decent, but it's not. Could always be maybe a little bit better, which is why I got to get my Nikon camera set up on here because it's going to be glorious. Pretty cool. That works quite well. So I'm doing video here. I can do some stills to the eyepiece, which is nice. You can see that bright rim of cilia on the upper part up here. That really shows the long cilia sticking way out. Like a comb, actually. Much longer than the cilia on the rest of the body, and much thicker, because they're used to, you know, bring food in and out and debris in and out of the kind of oral groove there. And I'm seeing also little guys nearby. Some small critters. See, there's a very small flagellate, looks like, wigging out right there, almost in the center of the frame. So it came over with the sample here. it's spinning around, and it's pretty funny. So I'm going to stay here for a bit. I don't want to change the eyepieces right now, because although this is such a good sample, and I hate to ruin it, I'll get a few more different angles here, exposures. Let's do a little dark field real quick. Almost looks like a side view of a small reef fish. With a little mouth open in the left there, and then a big eye spot. It's funny. Let's try a couple quick pictures of that with this other camera. That's wrong lens. Ultra wide. Telecamera. You're not supposed to move. I'm trying to get a shot. Alright, let's see if this one works. It's cool that little part looks like it's just spinning around. Almost like it's a motor inside, but it's just a whirl of cilia seen from a different angle from the top. Looks like a little whirlpool. Not sure why it's going backward constantly, but it likes to go backward. Let's do another kind of exposure here. Tweak the colors a bit. A little more striations there, that's nice. Now, the way the focus is, you can see how there's an arc. There's kind of an arc there. It's going back and forth, and behind that's the kind of the oral groove being seen through the cell. It makes a little more sense why that one part it looks like it's spinning, but it's actually all integrated to that loop at the top. But I love that part, upper left there. Looks like it's almost like a micro-spiral galaxy in high speed, swirling around, or a whirlpool of some kind. Very cool. It's just an optical illusion, though. It's not really doing that, of course. Let's go a little higher for a bit. This is back to the color again. There's some nice kind of granularity of the cytoplasm. Look at that detail. It's nice. And the vacuoles are all there. All those little spheres. The upper left kind of oblong-shaped vacuole structure that compressed a while ago, like it's a contractile vacuole, but I haven't seen it repeat, which is, I guess the cell is balanced, but normally those are pumping away, especially on the paramecia. Now it's the upper right. As it's rotating. It's a little more dark. Now you can see some of the cilia spinning in that circular structure again. Get a little hint of striations here. To change focus for you to really see it. Go over this way, you can start to see them. Longitudinal striations there. Very much like the striations in blepharisma, which I had on another stream. This guy's just doing a nice slow turn. Don't have to chase it. Just showing off for the camera. Change exposure again. Get some more details. This will show some more of the color that you see. You just look at it fairly normally in the microscope. Looks kind of green and striated and a little bit grainy looking. And if I change the focus a tad, you can see the cilia beating at the bottom. It's part of that oral groove opening. I have to basically change the exposure for you to really see them. Now you can see them dancing there at the bottom. And again, it's all around the cell. They're totally covered with cilia, but they're much bigger and longer at that oral opening at the bottom there. This animal's right now upside down. Go back to where you can actually see the animal better. Then you lose the cilia. Kind of see the cilia beating a little bit, especially inside some of those structures. But when you expose for the body, you lose some of the edge cilia that is too faint. Oh, now it contracted again. And again, nothing really happened. But it perceives some sort of threat. You can watch it unfurl now. Sometimes it takes a while. You see rotifers do it all the time, very quickly. But they're also much more complex organisms. They're about 1,000 cells. This is just one big cell. Focus through all those vacuoles there. Look at that. So this shows some more of the cilia on the rim and in the center there from that, looking through the cell and that opening structure. But then if I focus through, you'll see more of the vacuoles. The cell is quite thick. You can see the striations now too, which is nice. Focus back to the other side. And just because I can, let's get some pretty good shots of this guy. So even if I lose him, like I did before with the other one, I'm going to risk the oil immersion. So let's try some of that. Because then you get some nice up-close shots. And it's not moving much, it's perfect time to try this. So at 1,000 power, if you guys have seen this before, the refraction of light through the optics is imperfect, so you actually have to do oil to change the refractive index of the light. Wow. Those are the striations up close. Look at that. That's insane. Let me change the light on that. So those little striations you saw, this is them at 1,000 power. Turn some more light up here. Fix the just get as much light as I can in here. This is a pretty dark view, but it's very, very nice. If I can fix that a little bit more. You can see them shifting as the animal moves. That's a trip. A little bit greenish in this microscope view, but the light levels are quite low in the camera, so they're not showing up green. Just imagine they're the same color as that green you saw at the wider view. I'm going to start scrolling around a little bit here and see what else I can see. There's some cilia on the edge, dancing. That's the cilia near the rim that creates the, look at that, wow. And you can see stuff inside the cell moving around. Look at all that. All the inner workings of the cell doing their business. As we watch the cilia, you can see above, dancing through the striations there. You see them kind of contracting, almost like muscle fibers. It's really interesting. So these look like long eyelashes here. Very organized, very thick. Oh, it's starting to contract again for some reason. Look at all those little doodads moving in there. Very busy cytoplasm. Wish I could make it a little bit brighter, but I can push it a little bit with a condenser, but then I start to lose some other features that I like, so let's see what I can do here. It's about as bright as I can get it right now. Look at that. Those little dots making up the striations. Like I said, they're green in the microscope, but I'm just not getting as much light to the camera as the eyepiece is seeing. I'm going to try and take a picture with my camera, actually. That'd be nice. With my cell phone. Scope. I should put the bracket on here so it's locked. I'm going to try that real quick. There's a nice bracket I have that locks the camera on the eyepiece itself, so I don't have to keep adjusting it. Let me go grab that. Hold on a second. This should be good. I'm going to bump the scope just a little bit while I get this set up, but I think it'll be worthwhile. It's a bit fiddly. Actually, I haven't used this mount in a while. This is the one I used to have to use before I got a proper. Oh, there we go. We're getting close. Lock that down. You can see that green area inside there. What's going on with that green area? So it's so green it shows up really well in this shot, but it's even more green in the eyepiece. So get a little bit better view here with the, as far as the colors go. Get a really nice view on the eyepiece with the camera. Is off a tad. That's pretty good here. So I'm doing simultaneous video. I'm shooting video through the iPhone on the eyepiece, and I'm also doing it live on the camera. USB camera hooked into the microscope. It's not quite what I wanted to get out of it, but it's different. It's a different view for sure. You can really see those striations moving. The little Stentor, very nice. So you see the column shifting there? Like I said, the dots are more green in the eyepiece. I'm getting a little more of that on the iPhone bolted to it, but it's still off a little bit. But it's fun to see them moving, almost like bundles of muscle fibers, although they don't have those. Toward the bottom, you can see the some motion there, or that. All kinds of activity inside that section. Things streaming around. Oh, I see what happened. I have an offset. Let me get these guys back on track because they're not showing quite the same view. Shift this around so I'm seeing more of the same stuff. Three dots there. There we go. That's pretty much what I'm getting in both cameras now. Sure what those green areas are. I thought it was food at first. But now I'm not sure. Let's do a little tour here. Since it's not moving too much, there's the edge with the cilia again. What's going on here? Looks like is it making a food vacuole here? Yeah, it looks like it's engulfing this area. That's cool. Watch a live food vacuole being formed. Oh, wait a minute. It actually just lysed. Oh no, I think the thing is actually dying. I think the cell just lysed and it's spilling out its contents. Yikes, time to go back out a couple levels. That's not a good view at all. Yep, it's breaking apart. You just saw the cell membrane rupture as the animal was expiring. Yikes, look at all that stuff spilled out. So what it looked like was eating with some of the membrane bulging in different directions before it lysed. See, the vacuole's already spilled out into the water. This part is still intact. Will probably break apart shortly. If I go to dark field, you can see better what I'm talking about. This is just debris. All the black area is water. And all the kind of gray, bumpy area that's just kind of a mess is all the cytoplasm spilled out into the water. Some vacuoles there. It just totally lysed and everything is spilling out in different directions. So it could have been it's just its time to die. It could have been a pH thing, a temperature thing. It didn't even happen during the... there's still water on the slide. It's not dried up. It just wasn't happy for some reason. But you get these kind of beautiful prismatic colors in this dark field. Don't really see that when it's not dark field. See, now it's the typical kind of greenish color that it was supposed to be before. All the contents spilled out, so the vacuoles are all loose. They eventually break, but they haven't broken yet. All these little bits coming out, which I thought it was collecting to feed on, as the membrane was swelling around them as they were spilling out from different parts of the cell. That's too bad. Everything dies. But why this guy died, I'm not sure. He was doing quite well for a while. There's still plenty of water on the slide. So there you go. Let's go to large view here, and you can see much better what happened. There's still some of the shape to the kind of compressed form it had from when it was basically not happy. Like they contract down as they get, feeling they're being disturbed or whatever. But all this debris here, all around it, all this is all the cytoplasm that spilled out. Because the cells, of course, are under pressure. And since they're higher salt content and other contents that are going against osmosis, which wants to equalize pressure. So salty water mixes with fresh water, and water wants to find a balance. And the cell is constantly, your cells do the same thing in your body. They're constantly fighting to keep their shape and not explode. So if you put like red blood cells in fresh water, you'll see them start to balloon. They'll lose the donut shape that they have, the little compressed donut dimple shape, to being like a balloon ready to burst, and then they will eventually pop. That's why you give someone saline solution in their IV and not water. If you do water, you're starting to kill blood cells on a mass level all through the body. Very, very bad. So okay, poor guy. He's doing really well for a while, and that's it. Nice while it lasted. Let's do a quick check around the cell. I'm at low power. I'm in around the slide just to see if I missed anything. See, there's plenty of water. There's the waterfront. Yep, nothing else. Other little bits of stuff, but not one of these guys. Let's go back to where that debris field was real quick. Just so again you can get an idea of how big this guy was. Oh, I lost it already. Where did it go? Just below all this junk here. Not that far over. That's why I lost track where it was. It's definitely inside the boundary of the slide, the cover slip. Oh yeah, see now the air bubbles are starting to advance and the water is retreating. Well, I lost track of where the guy exploded, but oh, here it is. So yeah, this is low power. So this is basically 40x. Lowest power the scope has. And you can see how big it was. Now it did break, and all the debris spread all the way through here and way off that direction, off the cell, off the slide. But you can see this is still about the size that it was before it died, and is a collapsed form. So it's a big animal for sure. At this scale, a paramecium would be, maybe about that big, something like that. So it's a big animal for sure. So thank you, Stentor. You're a very good subject. Sorry you met your demise too early. Again, I don't know what happened, because the slide still has plenty of water on it. And with that, I think I'm going to stop, because it's mainly about the Stentors tonight, and I might still have some in this tube. I don't want to have any issues and go through all of them tonight, so I'm going to put these guys back in the fridge. Hopefully they, if I have a couple left in here, they will be okay. And so thanks for anyone watching the replay. I didn't have any. Teeny dropped in for a bit and had to drop out. But for anyone who does watch the replay, I appreciate you coming by. And just to cover all the bases here, the music you've enjoyed all stream is Henrik on Bandcamp. He goes by JX3D. He's from Denmark. Just as a refresher, I'll give you the link here to the actual album that played the whole stream, just kind of looping around. This is the album here. And if you go to that page and just go to his main listing, you can see he has many, many albums up there, including one he just released about within the last month or so. So please definitely go check him out, go buy his music. It's very reasonably priced, it's totally worth every penny and then some. And thanks to Henrik for suggesting I use his music on the stream. I'm going to use some of his on my astronomy streams as well, the MicroAddict 6313 channel on YouTube. But tonight I was doing this, and I figured, hey, I'll use some of his nice ambient music for the Stentor exploration. I was very excited to get some Stentors to look at and to study. So that's about it. So again, thanks again, everybody. Check out Henrik's music, JX3D on Bandcamp. Go buy some good stuff, support the man for his hard work, and he also wants to buy more tools, as we all do as musicians. They're not cheap. So that's all I can think of for now, so I appreciate it. And I will see you soon. Thanks again.